Okay. Good afternoon, everyone. Welcome to day two, the second session of the 3-day training session. Just to start off a recap from yesterday, we had a couple of presentations for those of you who were not able to join on the GMS in Africa project, an introduction to EU the Earth Monitoring Program, the Copernicus program, and the marine products also available. We had some insightful presentations from our colleagues from UMETSAT and the MyOCean Ocean International, telling us about the Copernicus Marine Service as well, and some use cases. We started with a little bit of an introduction to WEkEO and the products catalog. We're going to continue today. As I said yesterday, it's going to be a more hands-on session, a more practical approach today. I'm just briefly going to go through the agenda. We'll be looking at a demo, a live demonstration of the MyOCean Pro Viewer, and then we'll move on to the WEkEO platform. We'll take a few questions, move on to the second section, which is going to introduce us to Python and the development environments. Today, I have with me our speakers for today, Haley Everskane from UMETSAT, Fabrice from MyOCean, Elena as well from MyOCean, Elena Di Medio. I hope I got that right. And we'll also be joined by Ben Loveday, Dr. Ben Loveday as well, for the Python sections. So I'll quickly move over to Fabrice and Elena to start us off, because the first thing we're going to be doing today is to have an introduction to MyOCean Pro, and then we'll have a live demonstration. So over to you, Fabrice and Elena.
Hi, everyone. I'd let the floor to Elena for this demonstration.
Thank you. Hello, everyone. I'm Elena from the Copernicus Marine Service and WEkEO support teams. So I'm here today to introduce you. I'm not sharing, sorry. I'm here today to introduce you the MyOCean Pro Viewer, which is from Copernicus Marine Service. We decided to show you the MyOCean Viewer from Copernicus Marine Service and not the data viewer from WEkEO, just because they look quite similar, but the Copernicus Marine Viewer is more advanced and has some more functionalities, and aesthetically speaking is nicer to explore data here. And in any case, all the data that we are going to see here in the Copernicus Marine Service are available in WEkEO. So there is no problem about looking for products or downloading directly from WEkEO. So let's start. This is the Copernicus Marine Service homepage. To access the viewer, we have to click here on the ocean visualization. We see that we have three main tools of visualization: the MyOCean Learn, which is for beginners; the MyOCean Lite, which is for intermediate level, which means is to start exploring a bit the main variables across the global ocean. And finally, the MyOCean Pro, which is more to start exploring the variable itself, the products available, and so on. So today we are gonna, of course, see the MyOCean Pro. When we click on it, if it's your first time, you will end on this map. In this map, we see, first of all, that we have two layers, two variables on global ocean. The first, which is the seawater temperature, which I tell you now, it's a model, so it's a numerical model. And the second layer is the concentration of chlorophyll, again, in global map. It's a model again. We can see just to start here, we see the temperature. The chlorophyll is the second layer, so we can hide and show the layers, change also the priority if we want to compare them and put the priority to another layer. So now if I come back to the start, and you can start by exploring this variable, or we can start adding another product. So to add another product, we have to click on Add Layer up here, and we access the Copernicus Marine Data Store. In the Copernicus Marine Data Store, we have around 275 products. They can be, we saw yesterday, some models others are satellite observation, others are in situ observations. Everything is available here. The same products again are available in WEkEO, so no worries. And as there are a lot of products, on the left bar here we have the filters. Filters may be from free text search, so by keywords, inserting a keywords, or directly selecting the main parameters. Main parameters as the universe, if you are more interested in physical data like temperature, salinity, or waves, and so on. The white ocean for everything is high, so for high and very low latitudes. And finally, the green ocean, that it's for biochemistry informations. After we have the variables, the main variables, of course, we don't have the full list, but the main variables which regroups all the different variables. The area, if we are more interested in global ocean or some other European areas, and after the temporal resolution, the source, and so on. There are some others, so do not hesitate to look for them. For the case of today, for the example I'm going to show you, of course, I'm going to focus on the global ocean to be sure that I will be able to have the Africa. Let's say I want to choose the velocity. Velocity is good for in hourly resolution. And as we already have here in the background some models, I'm going to select satellite observation. So we have our research that filters from 275 products up to only two products. These two products, the main difference is the time range displayed. So here we have data for the last 3 years. Here we have data that are more for the last 40 years. In the case of today, I'm gonna focus on the near real time, so the ones that is more focused on the present. And when we click on it, we access the information page of the product. In this product, for this product, we have for every product actually. When we access an information page, we have this configuration for all the products. On the right, let's say we have the description with some important informations about the product. And on the left, we have different tabs. So if we stay in the description, we have a short summary with the DOI for reference. So all this will be useful in case you have any need to cite or to reference to this product in a paper, or in a publication, and so on. And after we have some other information that can be useful for you if you are not sure if it's a good product or not, like the spatial and temporal extent and resolution, the depth level if available, which is not always the case because we can have some products that are only on the sea surface and some others that are right, which is the case for models that arrives up to the sea floor. The main variables again, and some other information like for the download, the update frequency. So when the new data for near real-time products will be available on which day. In the notification tab, we have everything that is about the product itself. So if there is an issue, there is a maintenance, or there was an improvement on the product, it's here that you will find it. Now everything is fine because everything is green. In the moment something will be red or orange, it means that something is in progress. And we suggest you to look into it to read what's in the information. After we have the data accesses, which is the page where we will have all the data endpoints and mapping services. We have the list of the dataset, and we have all the endpoints available in Copernicus Marine. They are not the same than in WEkEO because WEkEO regroups all the Copernicus services. So it has to provide an harmonized access. You will see it later during this training today or tomorrow. But Copernicus Marine has some other accesses, which are Motu, OpenDAP, RDAP, especially for in-situ products, FTP, and WMS. If you are interested, but you don't know very much what it's about, you can click here on the eye and you will access the Help Center from Copernicus Marine. We work on it, so if you spot an error or something is not clear, do not hesitate to contact us. And here you will have all the information available, with some others, the redirection to other articles and so on. So you will be able to find everything you are looking for. After we have the contacts, so you can contact us via chat, online form, or email. And finally, which is very useful, and which for the moment at least WEkEO doesn't provide, is the documentation. It means that in Copernicus Marine and in all the other Copernicus services, each product has a documentation, a technical documentation about the dataset, about the variables, about the update frequency, the time range, and so on, and a more scientific documentation we call QID, the quality information document, where the data simulation information are written, where you can find the details about the validation results. Everything is about scientific domain, or how the data have been studied, how they have been validated, is here. If we are happy with what we are looking for, we click on the map and we have again the list of the dataset with the listed variables. In this case, this particular product is mostly, as we see, for currents and has three types of resolutions. So a daily, monthly, the hourly and monthly. For the example of today, I'm gonna choose the hourly because it's always useful to check currents in an hourly resolution, the highest resolution we provide. We click on Add to Map and we see that in the background, the map is displayed. If we are not happy with it, we can remove it, and it's very simple. We can close the window and we can start observing the chart. Before starting, I will show you we can see already that these observations here, the seawater velocity, has a yellow, kind of yellow-green color bar, but we don't have a yellow-green color bar everywhere. This means that, for example, in Mediterranean or in the North Pole, and in this case, this product doesn't cover this area because of satellites, because of the instruments, because of our observations, so they cannot cover everything. So it's also to show you the difference that we can have between models and observations. Of course, if you want to know more, as we said, we go to check in the documentation, and we will find why this is we have a lack of data, let's say, here. If you're not sure, I'm gonna hide that, so we can see very well that in Mediterranean we don't have data, but we have it for the rest of Africa, so very good. In the map itself, we can zoom in and out as I'm doing it. I'm trying to not do it too fast because it's hard, and we can change the projection if we want to study, for example, very high latitude or very low latitude. So if we want to conduct a study in the polars or in the high latitude, it can be useful to change the projection. Now we're back to the equator. If we focus on the map customization, we can see that each layers has this button here. The first, and I will focus on it later, is the subsetted download service by graphical interface. The second, the eye, will access to the, you will be able to access to the information page that we saw. This allows to explore the other layers from the same dataset. So as we saw from the same product, actually. So we saw that this product has 3 datasets. Each dataset has 3 other variables. If we want to change, for example, in this case, the resolution, I can directly do it from here. Or if even we want to change the variable itself. It's faster. You don't need to go to look again for. You don't need to do all the way to find the variable. You just do it from this tool here. And after, for the configuration of the layer itself, we have this gear here. With gear, sorry, here. The first is the opacity. Can be useful here if, for example, I show the temperature and we want to compare different variables within them. Now, temperature and velocity may not be the best example, but if you do the temperature and salinity, for example, you can check, you can compare them directly, just playing with the opacity. You can change the color map. Each variable has a color map already defined by default from us, by us. But you can change it, for example, let's see, now I put the Inferno color map. We see the angulus current that are more intense, they can be, are more visible. So it's up to you how you want to play with that, what you are trying to show. After, you can change, of course, the min and max if you want to focus, for example, in the case of the temperature, you want to focus on a specific range of temperature, you can change the min and max and just focus on that range. And for currents, that's why I'm showing you this layer, is because you can also add the vectors, which is very, very useful. You can add them just as a layer vector, means that you have the vectors. I don't know if you see it very well. You have the vectors over the layer of temperature in this case, or you can add solid and vectors, which helps you to have the intensity, so the speed of the currents defined by the color map, and also the direction defined by the vectors. So in this case, for the angulus currents, we see the way we see can help to find us the direction. It can help us to define if it's a cyclone or anticyclone and so on. So it can be useful. It's very, very useful. And for some of them also there is the log scale. You can change the scale, put it in log or not. Again, it is useful for this kind of variables, like also the concentration of chlorophyll. We have the log scale already applied, so it's not available for every variable, for each variable. Anyway, so this is for a first visualization of the map, a first interaction. Now, if we want to focus on more on the specific on particular phenomenon, let's focus here, let's say. I have other tools in MyOCean Pro that allow us to study a region, a specific region. We have here on the right, I don't know if you see it very well, some objects that can be created. We can create a point. So I want to focus here what happens. I want to see what happened. So we can create a point. We can create a line. Let's say here, and I want to study the same area and see what happened during a certain period. So we see that for each object, there is some graphics that appears. For a grid point, which we call a grid point for a longitude, latitude, specific longitude and latitude, we have the coordinates here, the values, the time series. So in this grid point, we have the seawater velocity, that the variation across the time, the depth profile. The same graphics are for a line where we obtain a transect with the depth profile, and for an area which we obtain an histogram. You see, as I created each graph, as I created each object, we obtain some graphics that are created by default. Every graph can be deleted, or you can also add new ones. And if I start looking for more info, we can also go to export a sample to CSV. We can export the graphic to CVG format. I'm gonna make you an example. I'm gonna show you an example. We can increase the resolution, and as I say, we can delete it. I need to warn you, these three options here are available for users of Copernicus Marine. So you need to have an account, a Copernicus Marine account. Everything is free. There is no worries about that. Just the WEkEO account will not be enough. Anyway, the rest of visualization, everything is free. Only in the moment you want to store something, you will need a Copernicus Marine account. Now, if I go back to what I downloaded, for example, for the time series that we were observing, we obtained this graphic, which is, let's say, a zoom of what we obtained here, that for the moment we cannot change the size. Well, we are working on it. So at least we can obtain the graphic. If we want also to observe another moment, because we want to move across the time series or across the depth, here on the bottom we have the timeline and the depth level. So here, for example, by default, I'm set to tomorrow. So it's the last day available, which is today. If I want to come back more in the past, I have data since 2020. If I want to come back in the past, let's say October 2021, I can zoom a bit on the timeline. I want the October, 1st October. And we see that as I change it, everything in our map is updated. So the variable is updated, the graphics are updated, which means that my ear anymore doesn't cover too much, but doesn't matter, just to show you what was the functionality. We can also hide the graphics to have more space or delete the objects. And the same can be done for the depth. Now I can zoom on it. This product here, the velocity one, as we saw, we can check again here, only has 2 levels of depth. Now here in the bar, there are more levels that are available because our seawater potential temperature has depth level up to the seafloor. So if we want to change the depth, can take us a bit of time. Yeah, our seawater velocity will not change because it's not affected by this change of depth, as it doesn't have the value. But if we hide it and we check our seawater temperature, we see that here I am at 1,500 meters of depth. We see how the temperature changes, and in some region we see also the bathymetry appearing. So there are less values because there is less ocean, let's say, has the seafloor, the continents, the bathymetry or is appearing. So if I come back to my surface, and I did zoom, this one I hide it, this one also. Everything I show here is available for all the products, all the variables. I'm just juggling between the two variables because we have some problems with the servers. Can happen, so the map can take a while, and I don't want to spend too much time waiting for the map to update. It can happen sometimes. It's the server if there is too high capacity. Anyway. There are other settings also in the map itself. We can log in or log out. Here I'm already logging in, but if I can log out, this is what you will have. If you don't have a Copernicus Marine account, you can register for free. or you can just log in. You can change the settings of the map, like show or hide the base map, show or hide the 10 degrees graticle, change the projection, change also the objects, the units of the objects. Us, we work in kilometers, but if you want to work in miles, you are free to do it. There is no problem. And finally, the last, let's move, let's come back here where we were. The last functionality I wanted to show is the download. Of course, as I click on the download, I have to log in. That's why I left it for last one. It was wrong. Because it's the main functionality is very similar. The interface, let's say, is similar to WEkEO, so you will have to insert exactly the same parameters, of course, in function of the product, but the idea is the same, to subset the area, to subset the parameters we want. But as you need a Copernicus Marine account, I didn't want to impose it too early. Anyway, let's see. I click on the download, subset and download button. I log in. I have some parameters to insert, the geographic area to specify, the date range, elevation range. I can, to define the geographic area, I can define it on the map by creating an object by myself. It can be a grid point. It can also be an area. We can see that here the coordinates are updated automatically, or if I want, I can also insert directly by my own if I already know the coordinates. I can also change and select the time range by hand using a calendar here, or using directly the timeline app in the bottom. Can click on HASI map to be sure I'm on the 1st of October. If I move to 31st of October, so perfectly, I have a 1 month. I click again as a map. The map here is updated, everything is fine. Here, the size is changing, is updating. And finally, the elevation range, I want to stay, I don't know, for example, let's say I want the 10 first meters of depth. So I have the surface here and the depth, the deepest level up, or again, I can do it from HASI map. Now, unfortunately, this dataset for the temperature as for the seawater velocity has only one variable. Some other dataset has several variables, so you can add other variables. I show you the example for chlorophyll. So we will download the chlorophyll and some other variables that we can decide, or all of them. You can just click on or add all or clear all and select them. You can also see that between the two layers, the same parameters are taken into account. So it's the same area, the same date range, the same elevation range. So you don't need to do too many modifications. Once the parameters are inserted, you are ready to download. You can click on download and just wait for the graphical interface to do it. You will have nothing else to do if not waiting for it. Or you can click on show API request and see and use the command line interface. This command line interface can be added to a script. It don't matter if it's Python, script in Python, script in R, in MATLAB, in Julia, or wherever you want. The module used is in Python, but this command line can be used in no matter which other language, so it's not a limitation. However, as I say, this is an API just for Copernicus Marine. There are some others, always in Copernicus Marine. You will see that for WEkEO is quite different. The parameters are exactly the same. The selection is quite similar, so we don't think you will be lost. But to access is a bit different. Anyway, if you have any question, if you have any curiosity, do not hesitate to contact us. If instead you don't want to download the netcdf files, you can just you just want to save an image or to save a map or as it is, as you create in MyOCean, you can do it by clicking on share up here next to contact us. You have the possibility to share the link. You can copy this link here. You can share it to a colleague. You can save it in a bookmark. Doesn't matter what you do. The same configuration, if you copy it, it will be exactly the same. So you don't lose what you have done, what you have observed. You don't lose all the graphics. If you had some graphics, you don't have any problem. You can download an image which can be, we use it, we do that for in some articles, so you will recognize if you go in the help center. It's a very fast way to show a particular region, to show a particular phenomenon in a specific moment. It's very, very useful. You can create a video. It can be a PM4 or a GIF, or GIF, depends. You can define the start and date, the timestamp, the duration, and finally you can also copy and paste the embed link, which means that the map that we see here in an interactive way can be added thanks to this link in your script or in your website. Again, if you have any question which about Copernicus Marine or about WEkEO, the team behind is the same. It's us. So the way of contact us on WEkEO and on Copernicus Marine is the same. You just click on talk to an expert. You can choose the chat or the email, and you can go across the articles, read them, or just simply sending a message, and we will answer you as soon as possible. And that's all from me.
Thank you very much, Elena. So far, I think there are very few questions so far for you. But the first one has to do with how do we open the Copernicus account to use MyOCean Pro? Okay.
I share it again. The easiest way, if you already are in the I'm lost. If you are here in the MyOCean viewer, the easiest and faster way is to go up here in settings. I don't know if you see it very well. I'm trying to show it to you. Your configuration will be like that. So session, login, or register. You just need to click on register. You fulfill these fields. And when everything is okay, or mandatory, so well, do not skip them. And when everything is okay, you click on register, you will receive an email to confirmation, and you just have to insert your password, and that's all. After that, you will be able to access to everything we have.
Okay, thank you. Whilst Elena is trying as much as possible to address all the questions, I would also encourage you to make use of the question and answer tab to post all the questions so that we do not lose track of all questions. The other one is, can we have a link? Can we have the link of this platform? Okay, so I'll be posting that answer in the chat and in the question and answer section as well. And another question. Hi, Elena. Can you please explain how to use the CMEMS RSS feed to obtain information or updates?
Sorry, I'm gonna check the question.
The Copernicus Marine Service RSS feed.
And the
Can
feed.
you explain how to use it to obtain information or updates?
Yes, I can do it very quickly because it may takes too long, but there is an article in the Help Center where it's explained very in the details. The RSS feed is available from the Copernicus Marine page. We click here, we are on the home page, we go on user corner, so everyone is on it, the user's notification service. We click on it, and we have all the same notification that we saw before. We have the general, the improvements, the incident, the maintenance, and so on. If I want to go in the incident, I click on one, and here we have make this view as RSS feed. We click on it. We have the XML, and we will have to add it to your, can be an email. If you want to receive the alarm in the email, you will you can set the parameters, why for which filter. So the product source here, the region, the parameter for keywords, and you will receive it, the alarm, as soon as the parameters you selected are concerned. So if there is a notification created about the topic you choose, you will receive the email or the tweet or the message in your Teams or the channel you choose, actually. And for that, I will pass you the link in the chat. Here we have an article that enters very well in the details, so it will be easier for you, I think, for me also, to pass you directly this article. It's very into detail, so you will not have problem to set it for you. I pass it right now in the chat.
Okay, thank you, Elena. The last two questions. Is there tidal data on MyOCean Pro Viewer? And is there a tutorial for first users of this particular platform?
For both is yes. We have tidal data. Here is this product here, the Global Analysis Forecast of Physical 124, has some tidal data in the, it's hard to find a good product, but there is a data in the budget. Yeah, here, this data set has tidal data. So I will pass you directly this, and I will add also the link to the user manual and the scientific manual, so you will have all the information. And about the tutorial for a user, also again, a similar presentation is available in the Copernicus Marine Help Center. So you will just have to look for MyOCean. We have a lot of articles about this. So we have an introduction, common questions, the evolutions, because we work on it. And here you have another example of visualization of the visualization data on Copernicus Marine with a step-by-step guide. So you can review it as many times you want.
Okay. The last one from Gada says, can we download the layer data directly as the raster instead of JPEG from MyOCean Viewer?
No, unfortunately, no. But we can convert the data downloaded from NetCDF to raster. But for the moment, all the data we have are only NetCDF, and the layers we obtain are, for the moment at least, under JPEG format. There is also a way using the WMS service to obtain a KMZ. Maybe it can be useful for this specific use case, but for the moment it's not available directly by Ocean Viewer from the graphical interface. But I will pass again, we have another article, I will pass it again for the KMZ file format. And if in case doesn't answer to you, do not hesitate to contact us directly, so we will be able to enter in the specific of your case and to find a solution.
Okay, thank you very much, Elena.
Thank you.
And I'd remind you once again, if you have any extra questions that you might want addressing, please post them in the Q&A section, and we'll get back to you on that. We'll go into the next session, which is looking at the live demonstration of the WEkEO form, which will be handled by Haley and Fabrice. So I think, Elena, are you still going to be around in case any extra questions do pop
Yeah,
up later?
I don't move. I don't move.
Okay, okay. Thank you so much, Haley.
Okay, thanks very much, Ignatius. Hi, everybody. Can you hear me okay? Give me a thumbs up if somebody can. Yeah. Okay, good. Thanks. Okay, wonderful. So I have a relatively easy job, I guess, today, because I'm going to show you a lot of what I've shown you here builds very nicely on what Elena's shown you with the viewer from the Marine Service directly. But I'll talk a bit more about how it differs in the WEkEO sense, and also show you a bit more about some of the other points of access in regards to the WEkEO portal, which is mainly just our website front end. So when I say portal, basically I mean website. So I'm just going to try and share my screen so I can show you the website. In a second. Okay, you should be seeing my screen now. Hopefully you can. Is that sharing correctly?
Yes, it's good from my end.
Okay, good. Sorry, I'm quite new to Teams, so I'm not 100% sure where I am with it. Okay, so this is the WEkEO website, as you saw yesterday in Fabrice's presentation. But I was going to show you a bit more today about what's behind the scenes of this website, and more what you can do to explore the data that's also available from WEkEO. So we'll delve a little bit more into the catalog, how you can start working with it. And I'll point you towards some of the features that Ben will also talk about after this presentation, and indeed that we'll look at a bit more tomorrow. So hopefully this will allow you to build your knowledge a little bit. It might be a little bit repetitive. I hope it's not too much for you, but I think when it's a lot of information, sometimes it's useful to repeat. But as always, do ask questions if you have them in the chat. I'm more than happy to go over any parts I talk about. Okay, so here's the WEkEO website. Welcome. Hopefully most of you have been here already, and maybe some of you have already registered, so you can try and follow along and explore as well while I'm talking if you like. Most of the key information in the website is available through these tabs that you see at the top of the web page here. So we have services, data, computing, use cases, and support. Under services, just a quick click, you'll see you can get some information about the different services we provide with regards to data availability, infrastructure, and harmonized data access, as well as our user support, which is one of the services you're experiencing today with the training. This is part of what we do under user support. So you can click through there and read more information. I'm going to skip data for now because I'm going to go back to that in a minute. Under computing, you can see the information about what's available for free and what's available if you need to scale up to larger resources. You can find more information about those here. We have some use cases. Some of these you saw yesterday in the presentation for myself and Fifi. So you can also look at these in more detail. And of course, if you are using WEkEO and you're doing something interesting with it, we'd love to add your use case to our collection. We really love to kind of champion the users of the service. So if you are using WEkEO at all, do keep in touch with us and let us know how you're getting on. Lastly, then there's support. And you can see the different bits and pieces we can offer you here. And you can, of course, write to us using support boxes here, or you can use the chat in the bottom right. So that's most of those bits of content. Then over here on the right-hand side, you can see the button to register. If you click on this, you can add in your details and get an account for WEkEO. These are different to the accounts you may already have with the Marine Service or with us at EUMETSAT. Actually, doing authentication over multiple platforms is pretty tricky. So we're not able to do that for you, at least at the moment. Maybe something we'll be able to do in the future. But for now, if you're going to use WEkEO, you need a WEkEO account. So you can register for one here. But once you've registered, you can go and sign in. And as you can see, I have saved my password because I have terrible memory, so I have a password manager saved it for me. This is my username and account, so I can sign in. And it'll then take you back automatically to the front page of the website here. And not much has changed. You might see one thing that has, and up here now you have this thing called a dashboard, which gives you access to various bits of information and ability to manage your own account, as well as access some of the more advanced features that WEkEO can offer. I'm going to go back from that in a minute. We'll come back. First, I want to show you the data viewer. So let's open this up. And you'll see there's a couple of layers already loaded, but you'll also notice that this looks very familiar to the presentation that Elena's just given. So yes, the viewer available through WEkEO is built upon the experiences that the team at Mercator and their supporting staff had with this, the viewer that they produced. And so we've been doing something similar with WEkEO. It's slightly different, partly because we have to serve quite a lot of different types of data. So you don't have as much advanced functionality in this one as you would in the MyOCean viewer, unfortunately. This is just the nature of what happens when you're dealing with particularly complex satellite data that's not gridded and things like that. But you can use this to explore a much wider range of data. So it does have some benefits. And if you're just getting started with working with WEkEO and cloud computing and these kind of things, then this is a good place to start, because you can explore the data in quite a manual way, both the catalog and the data itself. And then you can progress from using it in this way to in a more programmatic way, which is something we're going to show you more of tomorrow. So I'll go back to that in a minute. But for now, just to orientate you again to the viewer, you can see up here on the left, you have the information about the layers. There's 2 already loaded here. We then also have the help button up here, similarly to the one from MyOCean Pro and Viewer, which you can then use to access support. We have an ability to move backwards and forwards through time at the bottom with the timeline with the slider here that you see, and of course up and down through depth where this is appropriate for the products. Of course, not all products are available at different depths. Mostly it's the model products that are, maybe as well some of the in situ, I think, but the satellite data is usually only available at that nominal surface depth the satellite measures at, or surface level, depending on if it's in the atmosphere as well. You can see on the right here, you have various options to figure out where you are in terms of location, to give yourself a lat and lon position, to measure the distance, which might be useful if you're trying to size a particular feature and see how large it is in scale. You can set your area of interest, and this is particularly important, I would say, if you're wanting to start learning how to subset the data. This is a good way of being able to choose the area of information you need, especially if you don't know the coordinates. If you've got an idea of a region already in your head with the latitude and longitude, you can manually enter them too, but using this button, you can, for example, set an area of interest, and appropriately, I guess, for this course, we might choose the entire continent of Africa. Okay, so let's look then in more detail at the layers. So if we go back here, as with the viewer you saw before, you can find out more information about the layers by clicking on the I tab, and you'll see that a lot of the information provided here is similar to the information that was provided in some of the Copernicus Marine Service layers. Exactly what's provided depends on where the data comes from. In this data catalog, we have data from across the Copernicus services and from the satellite operations as well. So you have direct from the satellites, all the sentinels, you have stuff from the Marine Service, Land Service, Atmosphere Service, Climate Service, lots and lots of different data sets. So this catalog really is trying to bring all that information together, and of course, different products, different information, different organizations. So it's not all, it's all slightly different depending on what you're getting, but the core of the information should all be there and available for you. So you can look at the information, you can favorite particular layers of products of interest, and you can also add to map. This one is already added to the map, so I'm not going to click it again, but we'll have a look again in a second at the catalog. You can change the color bars where it's possible. This is only possible with some of the layers where we actually have the data rendering live in the viewer, rather than it being a layer that we're importing from somewhere else. So we had a question just now about whether you can access the layers as rasters. So actually a lot of the layers that you see here are pulled in from other web map and coverage and feature services, for example. So some of those layers, you can't necessarily access them directly through here, but there are APIs where you can access them if you're interested. For example, UMetsat has one. We feed our layers into the WEkEO viewer, which we can have a look at if anybody's interested. What else did I want to tell you about this? So you can see in the seawater velocity product, if we look at the example here, that this is not just a single product, it actually has other layers within the data set, and you can see there's lots of them in here, so you can choose the different ones. There's also other ways of changing some of the visualization, so you can log scale things as well. Oh, and that adds the vectors, as Elena showed before. Close this one down. So that's working with the layers themselves. Now let's have a look at how we can add a new layer. So this is going to take us into the WEkEO catalog in a bit more detail. If you click on the plus next to the layers, you can see the catalog of data that's available through WEkEO. And this shows you, I think, really the breadth of different data sets that are available. So you've got the different services here that I mentioned before. You've also got the different satellite problems. And I said to you yesterday that there wasn't Sentinel-6 data available yet, but there is Sentinel-6 data available now. This is a really new thing. So we have Sentinel-6 data available now as well. It's only the reprocessed data. We don't have the day-to-day data in there yet, but it is available. So you can start exploring that if you're interested. You can also search by sensor. So if you know the sensor on a particular satellite that you're interested in, you can search by that. You can search by area, similarly to what you can in the marine survey. Data that's forecast or in the past, and you can go through and search by a variety of different tags based upon various different application areas and variables of interest. You also, I think here, look by the originating sensor. So if you want to see all the data UMetsat's providing under its Copernicus activities, you can click there, or from the other organizations that are involved in the Copernicus program. So let's have a look at an example, and I'm going to choose the Marine Service since they're here and we're doing marine stuff. I'm going to look globally, and I'm going to select a sea surface temperature product because we're going to look at some sea surface temperature data tomorrow. So this is giving you a bit of a heads up for how you might find this data. So I'm going to choose here this Global Ocean OSTEA sea surface temperature and sea ice analysis. So this is some data we work with quite regularly for looking at long time series global coverage of sea surface temperature information. And I'm going to add that to the map. You can choose it at different spatial and temporal resolutions, as you can see here. And I'm actually just going to pick the top one here and add the sea surface foundation temperature. So we should now see that my map changes behind the scenes. And you've got a very complete looking sea surface temperature product. So this is actually a, I believe it's a level 4 product. Let's have a look. Was it level 4? What do they say? Yes, they do. It's a level 4 product. So this is should be complete in terms of gaps. I think it's filled actually with microwave data as opposed to gap filling gaps. So if you want to know a bit more about how that works, different types of sea surface temperature measurements, some can see through clouds, some can't. Happy to talk about that more in detail later if anybody's particularly interested in sea surface temperature. But yeah, effectively you're getting here a gap-free product. So you can see we've loaded it there, and we've got some options to work with it here. And what I wanted to show you is how the download works. So Elena already showed this from the MyOCean viewer, and it's very, very similar in the WEkEO instance here as well. You can copy in that area of interest. That's why I said it before, so that I could copy it in here now. You can set your start and end dates. You can choose the variables that you're interested in if you want to subset, and then you can request the data. And this will add the data into what will pop up here as a job, and then you can click to download it. But one thing I wanted to show you before I do that is this thing here called Show API Request. And this is where you can start moving from being a user that goes and searches a catalog manually, clicks and adds the products, and then clicks to download them, to a user who can make requests using programming language. So this is kind of where we want you to get to, hopefully by the end of tomorrow, that you can do this kind of thing, and we'll show you more about that then. But just to show you here that what you can generate from the viewer, and this is a really good way of doing it if you're not familiar with these types of techniques for accessing data, is you can generate what is called an API request. So this format here. It's actually what we call a JSON format. If you're interested, again, I can talk to you more about it in detail, but just to let you know that this is kind of the way these search queries are formatted. You can copy this and you can use it as feed to your programming request to go and get the data. And we'll show you more about how that works tomorrow, but just keep that button in the back of your mind for tomorrow's session. So yeah, if I request the data, you'll see it send the request. I can then monitor it under my jobs and you can see it's thinking. Now, I think I've requested quite a lot of data for quite a lot of time. So it's probably going to take a bit of time to come back to me. You can still see the API request there. But once this is done, it will show up in there and you can click and download the data manually to your local computer. This will do. When we talk more tomorrow, you'll see that you can actually also do this within the WEkEO infrastructure. So you can actually download this data or bring this data still in the same system from the catalog to your area that you're working. So in the Jupyter Hub or in the virtual machines, you can do this same process, and it's much quicker doing that than it is to download it to your own, because you're within the WEkEO ecosystem and all the fast kind of internet capability that affords you being within it. Okay, so that's the viewer. And before I finish up, I just want to show you another bit about the dashboard. So this is building on what I was showing before. So if I click on the dashboard. Oh, I've been signed. Oh, I'm signed in. Here we go. Okay, so you can see that I'm here listed as an essential user, which is effectively just the basic entry-level user type. If you've signed up for more computing resources, you'll see that this changes. Under here, you can do things relating to creating or joining a particular tenant. So this is an amount of resource that you've got already existing on WEkEO. You can access what is called Morpheus, which is a system that allows you to set up a virtual machine. So if you've got a free trial or if you've signed up for virtual machines, you can also use this. I'll skip the Jupyter Hub for now because we'll finish on that one because it leads nicely into the next presentation. You can access the WEkEO drive here where you can store and share files. So this allows you to share with other people within WEkEO and store and share information. There's also some other bits and pieces here, but we probably won't go into them today. These are much more sort of advanced usage. Maybe Fabrice or somebody wants to comment on them. But I'm going to finish by showing you about the Jupyter Hub. So if you click Jupyter Hub, here you can choose from a couple of different server options, and which you choose will depend on what you're doing. We'll explain a little bit more about that again later and tomorrow. But you can actually then start up a Jupyter Hub instance. Depending on how many people are using it, it might be slower or faster, but let's see how long it takes. It will then load up and put you into an interactive programming environment where you can start working with some of the tools that Ben is going to show you in the next session today. So just to show you that this is where the Jupyter Hub exists in the WEkEO infrastructure. And we'll show you this again. So if you've missed it, don't worry, you're going to see this several times. And with that, I will stop sharing and answer any questions that anyone has.
Thank you very much, Hayley. I don't see any questions yet, but I'll just give maybe a minute. Probably they were intrigued by the way you were presenting and demonstrating WEkEO. They forgot to note their questions. So just in case you forgot to put down your questions, we'll just give you a few seconds to note them down so Hayley can address them if you have any. One comment that came in was how some of the participants were interested in the training. Unfortunately, they cannot follow as much as they could because it's in English. They would have wished it would be in French as well. So apologies for that. We'll try and translate that material to you, and where possible, if it is even necessary to repeat the training and to have it in French, we would find ways and means to do that. Okay. I think everything was well understood. That means okay. Please come back about the differences between MyOCean ProViewer and WEkEO.
Okay, I guess I can summarize. So MyOCean belongs to the Copernicus Marine Service, and it only serves the Copernicus Marine Service data. As such, it has some quite advanced features that allow you to exploit that data more. WEkEO serves the entire of the Copernicus catalog that's available through WEkEO. And as such, it's not such a complicated view. It doesn't have quite so much functionality, but it does have more data behind it. So you have a bit of a trade-off. If you're just working with the Marine Service data, not with the Sentinels, etc., then probably it's best you work with that viewer. If you want to work with more than one type of data, then maybe WEkEO offers something different for you. But Elena, Fabrice, maybe you want to comment on that too.
Yes. Do you hear me? Yes. The difference between MyOCean and WEkEO. It's a good question. There are a lot of differences. Let's say that MyOCean, as we saw, has a little bit more functionalities because it's the ones our teams work first to make, let's say, test and to try the different functionality and development that will be applied after in WEkEO, in the WEkEO data viewer. Which is good in WEkEO is that, how we saw, we have all the type of Copernicus and Sentinel data that are available, so you can compare and observe all the Earth parameters at once. I don't know, there was another day, there was an example of study of the forest in France, at the same time with the impact of the ocean sea level, and the atmosphere, the impact that this can have on the atmosphere. Honestly, WEkEO is a very, very good good access if you have several parameters to check in a general way after. As this training was this training was most for monitoring of ocean variables. We thought it was a good idea to show you the MyOCean, but I'm not here saying that one is better than the other because the two are different. And in any case, for what is the viewer, the improvements in MyOCean will be applied to WEkEO. So they will be at the same level very soon.
Thank you very much for the clarification. And just to follow up on that, who should be contacted? Should there be any issues with WEkEO?
I would
WEkEO
recommend
support.
Support. Yeah, there's either through the support tab on the website, or I think the email is just support@wekeo.eu, something like that. But you can find it on the support tab on the website. That will then enter our help desk system, and they'll distribute your question to whoever is the most appropriate to help. So it could be our infrastructure teams if it's a problem with the Jupyter hub. It could be me if it's about Sentinel-3 data. It could be Fabrice or colleagues if it's about CMEMS training, these kind of things. So.
Okay, thank you. As a follow-up to that, I think Ben has posted also with extra resources in the chat, so you can follow up on that answer. On that note, if there are not any other questions, I think everything has been answered, Julie. And for those of you who are experiencing challenges with your internet, so you're not able to really stream this properly, the recordings will be made available to you, so you can watch them at a later date and not miss out on anything. Thank you very much, Haley. Thank you also very much, Elena. We'll move on to the next part, which is looking at the introduction to Python and Python development environments. This will be handled by Ben. I do not want to go into much of an introduction for Ben because he knows himself better and he's the first person to tell you about his credentials and all he knows about Python. If you think Python, think Ben. If you think Sentinel-3, think Haley. Okay, so over to you, Ben.
Thank you very much. Nice to meet you, everybody. I just have to set up my sharing because we're going to be using a few different windows and things this time. So let me just go ahead and do that. see how we do. What's the best way for me to do this? Probably. Oh. Teams issue number 1. Bear with me for 1 second. Okay, there we are. So hopefully you should all be able to see my screen. Let me just check and see, because I can only see a blank page and not what I'm presenting. It should be coming now. Fantastic. So I'm assuming that I'm good to go. So got a bit of ground to cover, and so let's kind of crack on and see where we get to. So welcome everyone to day 2. I hope it's been informative so far. We are going to move a little bit away from the satellite or marine data directly and focus a bit more now on the programming side of things. But before we do that, just a quick introduction to me. I'm Dr. Ben or Benjamin Loveday. I'm a marine Earth observation scientist and actual physical oceanographer by training. I got my PhD at the University of Cape Town, looking at the Greater Agulhas Current System. And now my main job is I run the Copernicus Marine Training Service for EUMETSAT. So I support the users in uptake of all marine data that we produce from the Sentinel-3 and Sentinel-6 satellites, as well as Copernicus contributory missions. And I'm also responsible for authoring a lot of the content that we've got on Jupyter Notebooks and different ways we can use Python to exploit our data. So I have you for 40, 50 minutes. We've got quite a lot to cover. So just to give you a bit of an overview of what we're going to discuss, we're going to break it into 2 parts. The first part will be a very brief introduction to Python. And the second part will be an introduction to Python development environments. And I will describe what development environments are, or my perspective on what they are, in the second half of the presentation. But for the first part, we'll spend about 20 minutes and we're going to focus on 4 major parts. And we're going to start with some programming myths, because I think one of the biggest barriers to programming is the intimidation or the worries you might have in starting something new. And it's one of my goals today to kind of like dispel that, to make you feel comfortable and confident in embarking on your programming journey. I would start by saying this is very much an introductory presentation. I'm quite happy to field questions later on about advanced uses of Python, but for now the content of the presentation is mostly going to focus on those who have not used Python or any programming language before, or have only taken the first steps into doing so. So on with part 1, introduction to Python. And we're going to start with some myths. And the first myth I want to present is this idea that I must learn to program to work with Earth observation data. And that is categorically not true. You can work with Earth observation data using some of the visualization platforms that Haley has already shown, such as the MyOCean or the WEkEO viewers. Or you can work with graphical packages, such as the ESA-Snap package, if anyone knows this, or QGIS or Envy. But really, to get the most out of working with Earth observation data, to really go in the directions that you want to go, especially if they're novel, or you want to work with a lot of data, programming will help you get the most out of Earth observation data. So it's not essential, but it's an extremely useful tool to have in your toolkit. The second myth I want to come to is I need a strong background in maths or science to learn programming. Again, this is completely not true. Being involved in programming is more like having a conversation than being engaged in a calculation. You can do many things in a programming language once you know how to speak it, and it's more like you trying to persuade the computer to do what you want to do. The computer often does much of the heavy lifting numerically for you, so you just need to have a better idea about your problem rather than kind of the science or the maths that underpins it somewhat. The last myth I want to come to is the idea of I need to take a programming course to start working with code. And again, this is not true. There are many open source packages, there are many online tutorials, there are many online resources that you can use just to start. And by starting a problem of any size, small or large, you will learn a lot more because it will be relevant to you, than embarking on a course that leads you through a load of tutorials that might be not relevant to what you particularly want to learn. So me, I am historically a MATLAB and Fortran user, and I started to use Python probably 8 or so years ago now. And I learned the most about working with Python whilst actually working with Python, as opposed to reading about or watching presentations like mine on how to work with Python. The best thing you can do is start to get your hands dirty and learn as you go. So those being said, and those being my kind of broad guidance to kind of make you feel a bit more confident about starting on your programming journey, which language should we choose? And there are an enormous number. And when you get this presentation distributed, you can click on this little choice paralysis button. This will take you to a Wikipedia article that shows you the enormous number of programming languages that exist in the world. And it's actually only the common ones. It's intimidating to look at this big list and try and decide which language would be the best for me. But some of them are very, very good for certain tasks, and some of them are really specifically designed for very, very small bits of work. And there are many you can choose from. The most common ones you would have encountered would probably be Python, MATLAB, IDL or R, and maybe some of you that might work more numerically, C, C++, or Fortran. But there really are 4 or 5 factors to consider when you choose which language to start off with. The first is, how fast is it and how scalable is it? Basically, how efficient is it going to be at solving the task that you want to apply the language to? And how big can you scale that into? If you want to work with 1 Earth observation scene, then maybe you don't need scalability. But if you want to work with 1,000, you probably do. The second thing to consider is syntax. How human readable is the code? How fast can you get to being able to do the work you need to do? Fortran might be the fastest language in the world, but if it takes you 2 years to learn it, is it really that appropriate for your task? The third thing to consider is licensing. Can you freely use and share the code? The fourth is, what packages and tools are available? What can the language actually do? Can it actually achieve all the tasks you want it to? And the fifth, and probably the most important, is how much support are you going to get when you get stuck? How big is the community? And so my justification for why choosing Python is that it has a big tick next to all of these options. Python is versatile. It can take on most of the tasks that you're probably going to want to do around Earth observation or marine data. And it can do so with specific packages that do next to everything that you want to attempt, all of which are very, very well supported. It is open source. It is essentially free. You're never going to run into licensing issues like you would with some proprietary languages like MATLAB. You can distribute it as you wish. The community is enormous. It's used across countless fields, including the scientific and technical communities, and it's very, very, very popular in Earth observation and geo and Earth science in general. And there are many examples of existing resources that exist out there on the internet that you can find that will give you training and support in these. And also, importantly, it's interoperable. It plays well with other languages. You can use Python to call other external tools. Many well-known software packages such as QGIS have APIs or application programming interfaces that support you using Python to interface with them. And it also will support you in things like access to external data records, such as Haley showed some of the JSON files or the automated API files that WEkEO provides, and we can use Python to extract data via these. So Python has a lot of big ticks across the board and does most of what we want to do in the Earth observation community, which is why it is so popular. And to give you an example of some of the people who use Python, so you don't think I'm going to embark on a language that nobody knows, EUMETSAT and the Copernicus Marine Service alongside NASA, big processors like IBM, Google, the entertainment community, Netflix, Instagram, Facebook, Reddit, all of these guys use Python as their backbone. So you really do get an idea of a software language that is appropriate for you to use and friendly for you to use on a daily basis, but also can scale into something that can run an entire company. So it really will grow with your needs and requirements. So where do I get Python might be one of the first questions that you want to ask. And the first point I'm going to get to is you might not actually need to. If you are watching this on a Linux system or on a Mac, then you already will have Python installed. If you choose to work on a remote desktop environment, which we will come to later, then Python will already be installed. If you're working on Windows, or it turns out you don't have a version of Python that you particularly want, or it's old, or you want to start from scratch, then there are many distributions available. There is one distributed by Python itself. There is one from a company called Anaconda, and there's another one from a company called Nthought. Now, the one that we recommend is a package called Anaconda, which I'm going to focus on a little bit towards the end of this presentation. So Anaconda comes as a Python distribution, but also with a load of packages that are going to be really relevant to the work that you do around Earth observation. And each one of these distributions also comes with a package manager. This is what allows you to go and get the extra tools that you might need to do specific pieces of work. And with Anaconda, you get a piece of software called Conda, which actually is going to manage those packages for you. And I'll touch a little bit on how we use Conda and Anaconda as I go through my demonstration. So once you've got your Python version installed, and I'll show you a little bit more on that in a second, how can I use it? There are a number of different ways. There are a number of different interfaces, we call them, between you and the programming language. Some of them are very friendly for you as users. You want to just pick up if you're new or do something quick, and others are more friendly if you want to do something in an automated way. So if you want to automate, or you are very, very familiar with the language and you just want to run some existing scripts you have, then you might want to interface with Python through the command line or the terminal. If you want to do something more interactive, so you want something that's maybe a little bit more like the MATLAB editor, then there is a version of Python editor called Spider, which might feel more familiar to you, where you can do some calculations and get some plots kind of on the fly and visualize it at the same time. Alternatively, and one thing we're going to focus on in the next 40 minutes, and definitely as part of my presentation tomorrow, is Jupyter notebooks. So these allow you to mix code with descriptions and plots to put code into a more kind of training focused environment. It helps with you being able to share your work with someone else to demonstrate what you were trying to achieve and to bring together kind of lots of different ideas in a way that's nicely shareable. So what does Python look like when you come to work with it? And what are the key concepts and syntax that make Python useful to us or friendly to use? One of the first things is it's quite human readable. So on this presentation at the top, you can see where I've written that section human readable on the left-hand side. On the right-hand side is an example of this. I can just have a variable, which can be anything I like, called this is my variable. And to print it to the screen, I only have to write the word print and put it in brackets. I don't have to do any other decorating around this or define any variables or anything. I can just literally just write that as if it was a sentence. Python is what we call object orientated. Everything in Python is an object. Now, an object is just a thing that travels around the entire of your code with all of the methods that are associated with that object kind of tied to it. So if you have, say, for example, in my instance, a string called hello world, then this string will always have a load of methods associated with it, no matter what we do. And we can type this little dir and then in brackets and then our variable command, and it will say, I'm a string, here's everything a string can do. And every string will have these methods. Python is modular, so you can import different functionalities into your scripts, into your code that will give you specific functionality. One of the most common ones you might want to work with is this package called NumPy, which lets Python work with array data much the same as MATLAB does natively. And there are other things you'll hear about, and I'm going to show you in a second. You have objects that are numbers, strings, lists, dictionaries, and arrays. And you can define these all very, very simply just by writing at a command prompt or in a Jupyter Notebook script or at the command line. You can define any of these as you wish. So I'm going to give you a very quick demonstration of this syntax, and I'm going to do it through the means of a Jupyter Notebook. I'm going to have to break my screen share and share a different window, so just bear with me for 1 second. Okay, so I'm going to share my entire screen, so things might look a little bit crazy for a moment. just bear with me. So I'm going to just move over to my command line, and I'm just going to fire up a Jupyter notebook. And I will go through a little bit more what I'm doing here later. I just want to show you what a notebook looks like. So here is me firing up my Jupyter server, which I'm hoping you can see. If someone in Teams can give me a little thumbs up to let me know that, that they're seeing that all right. And Q-Ignatius. So if I go to new, and I'm just going to define a kernel, it doesn't really matter what I do. And here is a new blank Jupyter notebook for me. So in here, I can do whatever I like. So let's see if I can first make it a bit bigger so you can all see. So welcome to my first Python script. And I'm going to say, let's say, for example, print. Welcome to my first Python script, which I'm never going to spell right, but I'm going to try. And if I hit enter, it'll do exactly what I just said. Welcome to my first script. Okay, so in Python, we have lots of different concepts. We have the idea of strings. So what I just wrote here is a string. So if we just say my string equals to hello world, this won't do anything. Then I can say print. Oh, sorry, my string, and it will print my poorly written hello world. I can say, right, my string is now a variable. What can my string do? If I look under my string and I put a dot, if I hit tab in Python, it will show me all of the methods that are associated with this string object. So I can say, if I want, and let's print this, my string.replace, and if I get this right, let's replace the letter O with the letter I. There we go. So all I've done is I've used one of the native methods for a string called replace to replace a single letter with another single letter. So far, so relatively simple. I can also make numbers. So my integer, 1. If I want to check that, if I do print and then I want to take the type, my integer, and I can hit tab to auto-complete my variables here, it'll say, okay, class is int. I can do the same thing for my float. Copy and paste this line. Ooh, badly. And it will confirm that I have a class called my float. And again, like before, if I want to look at float, I can say, these are all methods that are associated with a float as an object. So I've already defined a couple of different classes, a string, an integer, a float. What about some stuff that's slightly more complex? Python has this concept of a list. Now, a list is just, as you would expect, a series of pieces of information that are stored sequentially. So my list. I want to print my list and do so. Now, a list should not be confused with those of you who may be used to the concept of an array. A list is actually a very Pythonic way of storing data, and an array is slightly different, but you can't create arrays natively in Python. You need to use an external package to do this. And the package you want to use is called NumPy. So I'm going to import, because this is how I actually add external functionality into Python, NumPy. So now I have this method called, or this package called NumPy, which comes with its own methods. So now I can create an array. So I can say my array NumPy dot, and if I want to, and I can always hit tab to see what can NumPy actually do, and I want something called array my list. Now if I print my array, this is now not a list. You see there's no commas in it. This is now much more similar to a MATLAB array. And I can also ask for the type of this. Oh, sorry. That's what happens when you get an error. It's saying array doesn't exist, but my array does. There you go. This is a NumPy n-dimensional array. So this this now exists. So it exists as the type of an array. One other thing I'm just going to quickly show you before we move on to anything further is if I want to get the first number in my array, and this is actually very important in Python, to get the first cell, it is always a 0. Python is what we call a zero indexing language, which means the first element in my array is 0. This is element 1. This is element 2. So a number 0 will give me the first element of my array. Now let's just say I want to quickly plot my array, see what it actually does. I can't plot without importing another package, so I'm going to import a package I know called matplotlib. And this has a small module of it called pyplot. So now I'm not importing everything, I'm just importing this part of this package. And I don't want to have to type matplotlib.pyplot all the time. So I'm going to give it plot plt as an alias. So now I can say plot, and this has a method called plot, my array. And there's a little line plot of 1, 2, 3. Not very exciting. We could maybe make my array. Let's make my array a bit different. Let's make it 1, 3, 5, 7, whatever. That. And I've made a mistake here. Okay, and now if we do the same thing again, there you go. There is a simple line plot of my array as I just put it here. Okay, so that's my very quick introduction to using Python simply within a Jupyter Notebook. Just going to pop back to my presentation now. Okay, so once again, could you confirm that you're looking at my presentation? Okay, so that was my very quick syntax demo of using a Jupyter Notebook or using Python. We're going to come back to many of those elements in our second session, but before we do, we covered quite a lot, so maybe we should take a couple of minutes for questions here before I move on.
Okay, as Ben indicated, if you have any questions so far before he proceeds, I think we're having a little problem with the Q&A tab, so just feel free to drop your questions in the chat section, and then Ben will be delighted to answer them for you. No questions yet?
One question.
Oh, okay, that's one question.
So knowing which module you want to import is the kind of the meeting of experience and Google. You don't know, unfortunately, what you don't know, so it just takes a little bit of searching around, either Googling what you want to do, or by looking at code from people who are doing similar tasks, or by using online forums like Stack Overflow to search for specific things you want to do, because usually that will represent a good community of practice or a good first place for you to go to look for similar tools that other people might be looking. To give you some ideas of some common ones, NumPy by default is part of Anaconda. You will never not need NumPy. Matplotlib is the default for plotting. If you want to make any maps, there's a good one called Cartopy. I'm trying to think of other ones that are really common. Xarray for working with multi-dimensional data, and NetCDF. I think those are probably the most common ones I would suggest off the top of my head. But if you look at some of the code that I will show you later on, you'll see they have a load of import statements at the top. and each one of those import statements has a description of what they do. So you might be able to get some information from there. Question from Gada. To use Python within Jupyter and Windows, you need to download Anaconda. Yeah, so it's that is largely true, but slightly the wrong way around. Jupyter kind of sits within Python, not kind of vice versa. But if you get the Anaconda distribution for Windows, it will come including Jupyter Notebook, and you'll be able to launch Jupyter Notebook through there. And I'll show you a little bit about how to do that in a moment. Evaldo, I think we'll have to wait for your question to Ignatius at the end. And I'm not sure why someone else can't see my slides, because I should be showing at the moment, I think. They'll be available at the end of the presentation anyway, so we'll distribute them along with the recording of this session. How can we install package NumPy? If you are already in Python and you have the Anaconda distribution of Python, then I'll reply to this one in line. You can simply use the words import NumPy. That will automatically install NumPy. If you do not have NumPy installed, then I'm going to show you how you get NumPy installed in a minute. And I think probably in the interest of time, I shall move on. I can't really speak to VS Code instead of Jupyter, to be honest. So I'm afraid I can't really help with that one. Okay, let's move on to our second section. Okay, so I should be on my presentation. Welcome to part 2, Python development environments. Now, I've put 3 banners up here because they're probably 3 of the most important, or 3 potentially the most important environments or tools that you'll use when you're working with Python. So pay attention to those 3 because they'll appear throughout this second half of my presentation. First question to ask is, what is a development environment? And it's actually a slightly ambiguous question in that it really has 3 parts. The first thing it refers to is where we want to do our development. And by where, I mean where physically. Do we want to do our development locally on our own computer, or do we want to do it remotely on a cloud system? It also refers to how we want to work with our code. Do we want to develop through one of the interfaces we've shown before, the command line, through notebooks, through an interactive desktop environment? And it refers to what do we want in our environment. And this is a part we usually call a virtual environment, and I'll explain why later. This is how do we pull together all the packages that we need for a given project? More importantly, how do we protect the rest of our working world from that project? What if we want to run 2 different projects and they don't have compatible software requirements? So let's deal with each part in turn. Excuse me. Firstly, choosing an environment number 1, where? Now you are lucky enough to be starting or continuing your code journey in a time where there are a load of available remote cloud services that will support you in running Python pretty much wherever you like, with our advantages and disadvantages to both. But you shouldn't give up necessarily on the idea that sometimes local can be a really good choice for you to make. Local is always going to give you the most flexibility in terms of how you configure something. It runs on your computer. You install the Python, you manage the packages in an environment, so there is more responsibility on you to keep this managed. The benefits are you have total control. If it breaks, you can completely get rid of it and start again if you need to. You'll also learn a lot about how Python works. But there are challenges. You have a lot to learn in the first instance about how it works, and you might be limited by your local resources. Do you have enough storage to store the data you want to work with? Do you have enough memory locally to process it? Do you have enough bandwidth to be able to download all this data to your local site? These are often insurmountable and in terms of challenges, and so you need to look for alternative approaches. Also, you might be constrained by what you have available depending on funding, and cloud systems may be more appropriate for you. This brings us on to the idea of remote. So when we say remote, we just mean we're going to run on someone else's computer somewhere. This is all the cloud is, as the old adage goes. The cloud is just someone else's computer. However, someone else's computer is often 1,000 computers. So it gives you more benefits in terms of scalability. Someone else usually runs the installation and the management of packages and software environments for you, which means you don't have to take your time to manage it yourself. The administration is easier. It's often scalable. So if you write a routine that you can only run on, processing 5 Earth observation scenes per day on your local machine, maybe you can scale it up to 5,000 on a remote system. But there are more challenges. You do need a more regular internet connection. You don't need to learn about the setup, but this also means that if things break, then you're a little bit more beholden or a little bit more dependent on the people who are running the system. And there are sometimes limited resources until you decide or don't decide that you need to pay. However, there are growing free offerings, and WEkEO is one of the places you should definitely consider when looking to run your code in a remote environment, because the other major advantage, which I've not listed here, is proximity to data. Excuse me. One of the biggest problems you're going to face, and everybody faces it, is data is going to get bigger and more complex forever. So we're going to really run into problems of moving data around the world, and we'll have to move to approaches where we need to use remote platforms because they host the data for us, because we can't move it locally. Excuse me 1 second. The second thing of choosing environment is how do we want to interface with our code? We all code in different ways, so choose what works for you for your own purpose. If you want to build something quickly, if you've got a new data set, you want to have a fast look at it, maybe something like an interactive desktop environment is the best thing for you to try. If you want to batch process something, it needs to be speedy, it needs to run with minimal interaction, and maybe working with the idea of command line processing is the best for you. If you want to share your code, or if you want to train around it, maybe Jupyter Notebooks are a suitable kind of a suitable response or suitable approach. So we're going to look quickly at some options now, both inside Anaconda and on WEkEO, of what these 3 different interfaces look like. So once again, I'm going to break my share. And reshare my whole screen. Okay, so welcome to my entire computer. I am going to move now to, I tell you what, let's completely close this and show you from the start. Okay, so when you install Anaconda, and I've given you the link already in the presentation to where you get Anaconda from, you will get a thing called the Anaconda Navigator. It looks like this green icon that I'm highlighting that I think you should be able to see. Question from
Ben, I think we can only see your teams, just to let you know. I don't think it's sharing the Anaconda window.
Okay, it's just about to pop up, so let me know if it appears.
Okay.
Currently it's completely black, but can you see that Anaconda window or not?
No, all I can see at the moment is your teams window.
No problem. And now?
Give it a second. Yes, that's perfect.
Okay, so on my Mac, once I've installed Anaconda, then I have a little icon here in my sidebar that looks like a little green wheel, and this will open up my Anaconda Navigator homepage. And because I'm running on Mac, I have 2 of the 3 options I want to show you. I have Jupyter Notebooks, and I have this thing called Spider, which is this interactive desktop environment. Now, if you run this on Windows, you will also have something called the Anaconda Navigator, and this is a command line option. I don't have this, so I'm just going to quickly show you command line from here. So if I click on Terminal on my computer, I'm going to make this a bit bigger. And users on Linux will have the same situation. I've installed Anaconda, so I have Python native across my entire operating system. So if I want to work with Python from the command line, I can simply type Python. I am now in Python. So I can import NumPy because I already have NumPy installed on my machine. I can say print hi or hiu. So this is exactly the same as the Jupyter Notebook I was just showing you, except we can't decorate it with plots or put comments or do anything pretty around it. This is just Python at its kind of rawest on your local system. those of you who get the Anaconda Navigator or the Anaconda distribution on Windows, then you will use the Anaconda Navigator, which will look like a little prompt symbol to open this. So Python run from the command line, quite simple. For Linux users who might be a bit more advanced, you might have more than one version of Python locally. So sometimes it helps to type which Python, and it will tell you what your default is, and it should be the Anaconda 3 version to make sure you're working with Anaconda, because Mac has Python also natively. Other ways we can work with Python. Through the Anaconda Navigator, we can click on Launch Spider. So Spider is an interactive desktop environment. For those who've worked with MATLAB before, this is akin to what you would have had with your MATLAB editor. And so you end up with a console or like a little command prompt. It's exactly the same as what I had from previously with the command line, but I can do more advanced stuff in here, such as write directly inside a script and see error output in my console. And you can also enable plotting windows in here. But again, you can do things like import NumPy, print hello, and it will give you little clever code hints to tell you about the methodology you're using. But essentially, it's the same as the command line of Python, but gives you a little bit more interactivity. So if you want to do something quick, some prototype, then this is a nice way to go. The other option we have is to work with Jupyter Notebooks. Now, I can choose to launch that from here, but in the interests of this course being WEkEO focused, I'm going to show you how you launch these on WEkEO. So, hopefully you can see my browser, but I'm just going to go to WEkEO.eu. When I'm on WEkEO.eu, I'm going to go to sign in. I already have a WEkEO account, so it's going to give me my details. When I sign in, if I go to my dashboard, then I can go to my Jupyter Hub from the left-hand side. And someone already asked this in chat. It's going to give me 2 different server options. And I'm going to go to Earth Observation Tools because it's the one more appropriate for me. And click on Start. Let me just make this a little bit bigger for you. And this is going to fire up the WEkEO Jupyter Hub, which is a remote server that hosts a load of Jupyter notebooks that are relevant for working with marine data. But you're also free to create your own notebooks on here as well once you have an account. So now I'm on my Jupyter Hub. I can, I can choose to create a new notebook. So I have 2 choices here, and I'm going to come to dealing with kernels later, but for now it doesn't really matter which one you choose. So let's just go with Python 3 kernel. And if I click on this, I'm now in Jupyter Notebook. And all you have to do to reach here is apply for a WEkEO account and follow the 3 or 4 clicks that I just showed you, and you now have access to a remote cloud Python server that will run Python inside a Jupyter Notebook for you. So we've got those 3 different interfaces that we can use for our Python needs, and they will vary depending on what task we want to achieve. Okay, so again, finding and popping back to my presentation. Tell you what, rather than do that, let's just do it from here because I think it will probably work the same. Okay, so we've looked at where we might want to run. We've actually shown you 2 examples of running locally through the command line and through an interactive desktop environment, Spider, and 1 example of running remotely through the Jupyter Hub that is on WEkEO. I just want to point out another available server called Binder. We use some of our marine training notebooks here. Binder is nice because it will just configure Jupyter notebooks ready to run for you, but it is limited in that once you finish with the session, it is gone. You cannot make any changes and save them. It has no persistence whatsoever. So it's temporarily useful, but I advise you to check out WEkEO for all of your Jupyter notebook development needs around Earth observation or marine data in general, especially where that data is hosted on the WEkEO system. And we just had a brief look at how. So one of the last things we're going to come to is what packages do I need? So a package is a piece of kind of mini software that achieves a specific task around the data that you are working with. That can be numerical methods. It can be set of plotting routines. It can be SQL database work. It can be one of a number of different tasks, an almost infinite number of tasks. And it takes some time to learn which ones you like and want to work with, or to find new ones. And in fact, Anaconda comes bundled with most of these packages that you would want on an everyday basis. And the Jupyter environment on WEkEO has even more installed that you might need. However, you're always going to run up against scenarios where you don't have everything that you want. And all Python packages, or Python distributions rather, have package managers such as Conda to help you install what you don't have. So I'm going to very quickly show you how you add packages in various environments, and it's largely the same on all three, but I'm just going to quickly show you in the command line because I think that's one of the easiest ways for me to show you. So for an example from the command line, let's say I'm happily working away in Python. Let's type Python. I'm in a Python environment. Import my NumPy, and I'm going to say, okay, my array. And then you're going to say, okay, my array is array 1, 2, 3. And I'm going to say, okay, now I'm going to plot my array. I'm going to say, what is plot? I don't know what plot is. Now I'm going to realize that actually I want to import my matplotlib like before. Okay, now I have plot. Now I can make this plot if I want. I'm not sure where that's going to go on my screen, but it's gone somewhere. But now I'm going to say, okay, now what if I want to work with something else? What if I want to work with arrays? And I want to import X array. Okay, oh, Python found that. Sorry, I already have it natively. I didn't mean to. Or let's try something else. Okay, what if I want to work with mapping data? I want to import CartoPy. And my Python said, you don't have CartoPy, you can't use this. How do I then go ahead and get it? The best way for me to get it is I can use a command called conda install and then the name of the package. And this will use the conda package manager to go and fetch the code that I need. An even better way to do this would be to set up an environment, a virtual environment in which I want to add this package. So inside my computer, if I do conda and list, it will list all of the environments that I have available on my computer. And you can see I do a lot of training on different things. I have all of these separate environments. Now, these environments, we'll come a bit more to environments tomorrow, are encapsulated kind of areas that contain a load of software packages that I use for specific tasks. So if I want to, say, work with Altry data from Sentinel-3, I know I can activate an environment. And inside this environment, I can list all the software I have, and I know that in this environment, there's a lot. One thing I do have is this CartoPy package. So I can use conda both to choose what environment I'm in, as in what little kind of compartmentalized room I want to add the software to, and then I can use conda itself to actually add to it. And you can run these commands the same way on Jupyter. So from the Jupyter Hub, you can choose to open a terminal. And if you want, you can type conda, and it will give you this use of the command. And you can add packages as you see fit into your Python environment remotely if you happen to be missing some from there. Okay, so that's my brief touch on virtual environments. Final thing I'm going to mention, because I'm fast running out of time, is getting code and sharing code. And the only word I really want to mention here is Git. Git is a way of tracking code. Fundamentally, it's a way of version controlling your code. So it can be shared with other people, and you know when you changed it, who changed it, why you changed it, and you can revert it back to a previous version if you want to, or if you see fit. It is also a very, very common way of distributing code via a couple of well-known repositories known as GitHub and GitLab. So we use this Git infrastructure to distribute our code from us, where we develop it, to the world in general. So for all of our training courses, onto the WEkEO platform, for example, or onto Binder, or between us if we're developing multiple things at the same time. And there is an instance on WEkEO. It's called GitHub, or if you go to just basically github.com/WEkEO. Again, let me make that a bit bigger. Oh, that part doesn't get bigger. Sorry. It will bring you to this environment or this web page. And on this web page, you can see all of the repositories that we work with that are going to be hosted or mostly hosted on the WEkEO system. Now, for Oceans, we have a group called WEkEO for Oceans. And on WEkEO for Oceans, you will find further down instructions on how you get this code and how you clone this code to your own computer or your remote system. And when we say clone, what it does is it makes an exact copy of this code, copies whatever is on this remote server to you, but also allows you to track any changes in that code that might happen on the server side, so you can stay up to date with any developments. Now, all the code from WEkEO for Oceans is actually hosted on Jupyter Lab. If I go into the public folder, you can see we've got WEkEO for Oceans here. And inside WEkEO for Oceans, we have repositories for working with Sentinel-3 data from all different sensors, and for ocean case studies, which we're going to come to tomorrow because we're going to work through one of these notebooks. And you can actually clone this code directly onto the WEkEO system, should you wish. Let me just say where I'm just in my home directory. So I can take this line here, copy the entire thing, and if I run this, it will copy all of this code, all of the Jupyter Notebook, everything I require to run this code onto my WEkEO system in my home directory, ready for me to use at a later date. So don't worry about this too much because we're going to come to this again tomorrow in our slightly longer demonstration. We've got 50 minutes. We're going to work through one notebook. I'm going to show you from start to finish how we get up and running on the WEkEO Jupyter Hub to work with data from the Sentinel-3 SLSTR sea surface temperature sensor, as well as from the CMEMS Ostia SST record that Haley showed you through the WEkEO viewer earlier. And I think looking at the time now, that should be where I end my demonstration. So I'd like to thank you all very much. Oh, sorry, one last thing. I have put a list to more resources on the page, which will be links to the definitive Python guide, a video that actually covers much of what I've shown today. I will also endeavor to get the recording and auto subtitle and translate into subtitled French for this presentation, as well as introductions to some good Python courses online that are free, and a great book, but not free, for Earth observation for Earth science data. And that's the end for me. So thanks very much. I'll answer your questions.
Thank you very much, Ben. Lovely presentation as always. And I'm guessing people are really waiting to have their questions addressed, but I don't see any yet. Oh, there you go. How do you get over the headache of transitioning from Python 2.7 to Python 3? Does this apply in WEkEO?
It does apply in WEkEO, and it mostly applies anywhere. If you want, you could probably build a Python 2.7 environment on WEkEO, but I would really advise to take the small headache hit now, because it's only going to become more headachy in the future. So unavoidable to some extent, I am afraid, you know.
All right, thank you. Oh, okay. Initially, someone just made a post about having a crash course in Python. Yes, it is truly a crash course, and unfortunately, this is just the introduction. We're really not delving much into what is happening in totality with Python. This is just a crash course. There's a repeated question. I think you've addressed it, but if you could do it again, what's the difference between Spider and PyCharm?
I actually don't use PyCharm very often. Actually, I don't really use Spider so much, so I can't actually answer this one. But maybe someone else here has used PyCharm and wants to give their input. Johnny?
Yeah. So I think PyCharm is just an environment like you have with the Jupyter notebook, but it's or like you have what you showed with the MATLAB thing. So it's just an environment. Is you put in your command and it gives you the same command you put in PyCharm, the same command you put in Spider, and it will give you the same result. So it's just an environment, different environment that makes the whole thing appear differently. That is all. There's not much any different.
Thanks. I confess these days I write nearly all of my code from a training perspective. So I use Jupyter for this. Where I write it for my own research, I tend to use just the command line and a text editor to write it. So yeah, thank you. A little note, by the way, on the person who asked for a crash course. Sometime in the next 2 or 3 months, we'll be releasing a 6-part video series on Python from start to running with our code. So I can keep you up to date on when that will be available. That will help from a UMets that perspective, but it'll be also translatable into using products from across the Siemens catalog as well.
Okay, thank you. I think Haley did chip in a bit about the earlier question between the differences between Spider and PyCharm. Spider is a bit smaller, so it runs a bit easier, but in all honesty, I think they are all IDEs, so it's just a matter of choice. And like Haley said, Spider is a bit lighter, so people prefer to work with that. Can we get the recordings? Yes, the recordings will be made available to you. It does take a while to compile. That's why you haven't received it yet, but I'll try to send it as quickly as possible. Today, via the link, let me know if you're able to access it or you face any difficulties, if we would have to post it on YouTube or any other platform to make it a bit easier to for you to access it, please let me know. If you we still have a few minutes to go. If you have any other questions, please let us know. And before, it doesn't necessarily have to be linked to Ben's session, because we had earlier sessions on WEkEO and the MyOCean Pro. In case you forgot to bring up those questions, also you can take them up now. How do you handle the challenge of an instance of a virtual machine being interrupted occasionally?
This is a very, very good question, and one that nearly all remote developers face at some point. To some extent, it depends what the interruption, what is the nature of the interruption. If the interruption is to do with internet connectivity between you and the virtual machine, then if you're working on something like WEkEO, then there's persistence on the server side, so you can go back to the place that you were before, provided you saved. It's something like Binder, you can't, it's just gone. However, if it's related to the virtual machine itself running into some sort of crash, then this is the kind of thing where you should send support to the provider to say, I'm experiencing problems with unreliability. Can you please let me know what's happening? So it really just depends on what the nature of the interruption is.
Okay, another question from Gada. What are the most powerful resources, from data format softwares to online servers, we can choose from when it comes to big data?
I would start by saying you're in the right place, because we are presenting probably the best free offering for working with marine data that you're going to find anywhere. All of the data sources have been brought together for you into one place that can be accessed with some consistency. There's remote cloud processing infrastructure that's expandable for you should you wish to be able to work with the data without having to move it to you. And you're also working with people that are used to supporting some of the most advanced uses of Python to work with this data, for instance, with AI, machine learning, on systems that are scalable enough to accommodate the size of those approaches. It is our job to work with big data and make big data manageable. So I would say you were in the right place for this. We probably are some of the best options you have.
Okay, since our time is almost, actually, our time is already up. I'll take the final question. Picking from your experience with the command line, which of either the terminal or the command prompt would you recommend?
I think
You understand that question?
If you're working on Linux or Mac, they are the same. If you're working in Windows, I would advise that you use the command prompt that is available inside the Anaconda Navigator, because this has the correct Python environment set up for you. Don't try and use, for example, the Windows command prompt that's in your start menu for this, because you'll run into all kinds of problems.
Okay, Haley had some additional comments on that as well. You can check on that in the chat section. Thank you so much for joining us today. From Ben to Haley, Fabrice, and Elena from MyOCean, we'd like to say a big thank you to you guys, and we'll hopefully be joining you tomorrow. Once again, we'll be using the same links for the meeting tomorrow. It starts at 1400. UTC or GMT, depending on where you are and how you want to access it. It's always available. The recordings will be sent to you via your emails. I will be posting them. There's been a suggestion of YouTube from someone in the comment section, so I'll be uploading them on YouTube, and this link will be to you on your emails. Thank you so much, and join us again tomorrow for the final part. Thank you all.
Thank you, everyone.
Thank you. Bye.
Everyone, see you tomorrow.